Shoot. Sorry, my microphone wasn't on. It's not going to be a great recording. All right, let me just back up real quick. So for sure, one of your functions is going to be a table or a graph. This one's a table. The other one is going to be in exponential, or in the other one is going to be in algebraic form. You're going to put the algebraic form one in the calculator. All right, and then part A1 is going to be a composition, and that's what we're doing. G of f of 4. All right, so G of f of 4. So where would you guys start? Would you start with the G or would you start with the F? We're going to start with the F. We're going to start inside the parentheses. So finding f of 4, you're going to go to the table. When x is 4, f is 5. So f of 4 is just going to be replaced with 5. Now, throughout this exam on the FRQ, you need to show your work as much as possible. I am really not sure on this question what they're going to be looking for as far as work. It's possible they'll just trust you to just do this in the calculator, but because we don't know, let's just go ahead and write out what you would do to find G of 5. So in the G function, you're just going to go through and make all of the x's 5s and write that out. Now, what I would do, if I was you, is not type that fraction in the calculator. We've already basically typed it in. And so if you're, if you're on the home screen and you want to find G of 5, and I know G is in Y1. Do you guys remember how to do that?
Alpha trace.
Yes, good job. We're going to do alpha trace. My goodness. We're going to do alpha trace and choose number 1, and then we'll just put the 5 in the parentheses. Now be careful. The question says that we want to give the decimal approximation. And because of the way I typed it in, I didn't get a decimal, I got a fraction. So if this was a question and you put 11/5, you would get nothing, unfortunately. So to find what 11/5 is, you have a couple options. You can just take 11 and divide it by 5. Or you can take that fraction and turn it into a decimal by doing math and then choosing number 2. So up to you. It's going to be 2.2 is going to give you full credit. 11/2 is going to give you 0, unfortunately. So we want decimals here. Okay, let's look at the next part of A. The next one is going to be some kind of inverse. And so this is asking us to find f inverse of 10. Now that is not the same as asking us to find f of 10. It's asking us to find what x value gives you 10. And so you would need to go to the table, and what x value gives you 10? 5. Good. Now, I don't think there's work to show on that one. I can't imagine there is. You just answer the question. Okay? And then the next one will be something like this one, where we're going to find all the x values as decimal approximations for which g of x is 4. It could possibly ask for the zeros, or where g of x is 0, or whatever. But in this case, we want g of x to be 4. Now, g, we have typed into Y1. If we want to know when this is 4, what do you guys think we put into Y2? 4. And then we want to find where these two cross. So those are the two places where g of x is 4 is the intersection of these points. Do you guys remember how to find that? Good. the second trace, and then number 5. All right, since there's 2, we will move close to one of them and then hit enter 3 times. So whenever this says intersection, it means it's an answer. If it says Y1 or Y2 or guess or something, it's not the answer yet. All right, and so I would just kind of make a sentence out of this. Let me move this down a little bit. All right, so I would say something like g of x equals 4 when x equals, and then how many decimal places do we need to be accurate to? 3. So you can write this whole number if you want to. You can write 4 numbers after the decimal point, whatever, but you just have to be accurate to 3. The person grading your test is only going to look at 3 digits after the decimal point, so that's on you. You can round or truncate. In this case, it's the same number, rounded and truncated. All right, and then we'll find the other one, same way, second trace 5, and then move close to it. And hit enter 3 times. All right, and then the next part of B is going to be an in behavior question. And it's only going to ask one side of the in behavior. It's not going to ask both. If you want to give both, you can, but they both have to be right. So I would just do one. I would just focus on one. So we want to determine the in behavior of G as x decreases without bound, and we're going to give our answer as a mathematical notation of a limit. So a limit has 4 parts. One part is limit, and then under that is going to be what x is approaching at this limit. So what is x approaching at this limit? Negative infinity. Decreasing without bound. X is approaching negative infinity. Right? The third part is going to be the function. So which function are we talking about on this one? G of x. And then the last part is what that limit equals. Now, this is a difficult question to get right for some rational functions. Because if you look at this, what does it look like is happening on the left? It looks like it's going to infinity, but it actually isn't. So you have a couple of options. You could take a second and type this into Desmos on your test if you want to, and then it's really easy to zoom in and out on Desmos. I'm not sure without a mouse if it's really easy. Or you could zoom out on here, and it might help you see everything. So if you hit zoom, and then choice 3, and then enter, you see more of the graph. So now on the left, it is actually decreasing without bound. So that's tough. That's a tricky question. The other thing you can do is do it algebraically. So let's finish this problem, and I'll show you how to do it algebraically. So what do you think this limit equals? Negative infinity. Because as x is getting smaller and smaller and smaller, over here, the y is also getting smaller and smaller and smaller. All right. Okay. So the way you could do it is to focus on either the horizontal asymptote or what the graph is doing. So there would be a horizontal asymptote if these degrees were the same, or if the numerator was less than the denominator. And so if there's a horizontal asymptote, that's what the limit is approaching. But this one there isn't. And so what we did when we did this before is we would divide the leading terms. So when we divide x squared by x, we're going to get x. And so this function at the ends is going to act just like the line y equals x. So on the left it's going to fall, and on the right it's going to rise. Anyway, that's how you can do it algebraically. Sometimes they make that a hard question to get right. Sometimes it's an easy question to get right. All right, and then C is going to change from problem to problem. So sometimes C is what this one is, and it is to determine if this function is modeled by linear, quadratic, exponential, or logarithmic. Sometimes it is about, is the function invertible? Do you guys remember what has to happen for a function to be invertible? That is for it to be a function. It would have to pass the vertical line test. For invertible, it actually has to pass the horizontal line test, but that cannot be your reason. So let me just...
Oh, because isn't like each input value is mapped to one output value?
Each output value is mapped from a unique input value. So what you said is for a function. That's really good to remember. So let's just make a note about invertibility. I might have just made that word up. It sounds like a real word. If a function is invertible, you have to be very specific of how you word it. And so it would be each output value. Oops. Of whatever it is, we'll say f, is mapped from a unique input value. That's what you would say if that is true. And if you're looking at a graph, if you're looking at a graph, you're looking for, it passes the horizontal line test. If it's not invertible, you just have to give an example of when this is not true. So you would say for not invertible, and I'm just making this up. This isn't about this function. You would say something like, I don't know, 8 is mapped from to and 3 or something like that. And that would be a situation where you have 2 is paired with 8 and 3 is paired with 8, something like that. That's not invertible. Okay, that is not what this question is asking, but last year on the AP exam, that is the question they asked for Part C. Now, this Part C, we practiced a ton early, like in August and September. We haven't done it a lot since then. So if this is going to be linear, do you guys know what happens with the output values? First, differences of output values are constant. Good. And we have to write more than what I'm writing right here. This is just to trigger it in your brain. We'll write all the words in just a second. And then for quadratic, it's going to be a second differences in the output values. All right, what about exponential? There's no differences here. Proportionate, good. So we're going to say something like the output values change proportionately. All right, and then lastly, nice. I'm so proud of you guys for remembering this. For logarithmic, the input changed proportionately. All right, so let's see what's happening with this function. Now, remember, this question will be on the computer. But you'll have your booklet to write all the things in. So I don't think they'll necessarily be looking for it, but it's fine if you write down what you get for the first and second differences. So the first difference is if we look at our table and subtract or see how much you've changed from one to the next, it's going to be -1, 1, 3, and 5. So that's the change in the output values. So it's not going to be linear. All right, then what about the second differences? Yeah, it's 2 across the board. So it is going to be quadratic. Now this part 1 of C, you don't have to give the reason. You just have to give the model. And so I love to quote the problem. That way you're not going to get something wrong. So I would start in the problem after if, where it says F. And so I would just say F is best modeled by a linear function, quadratic function. This might be the worst video I ever recorded. Sorry. Okay, and then part 2 of C is when you give all the reasons, and you have to be very specific about the words. So the reasons have to be based on the relationship between the change in output values of F and input values of F. If you don't talk about input or output, you don't get your point. If you don't talk about how they change, you don't get your point. So, do you guys remember how we used to start this? Right, so the second difference is, and you can abbreviate that. I just wrote it out for some reason. Are they the differences in output or input? Good. How are they changing? They're not changing, they're constant. Good. So our constant, and I think it's a good idea to tell you that they're a constant 2, like across the board. I think if you leave out the 2, it's okay, but try to remember to do it. All right, and then over. Nice job. I was worried you guys forgot that. Consecutive. That's the left. Yeah, equal length. Input value intervals. You have done all the things I asked you to do about the relationship between them. Yes, clap for yourself. That was good.